Hello everyone, I'm Nitin Reddy from EC. My topic is arithmetic instructions of 8051 microcontroller. Structure of assembly language. Label equal to mnemonic operand and common. Example, move R1 comma hash 25H, load data 25H into R1. In 8051, the registers are A, B, R0, R1, R2, R3, R4, R5 and R6 and R7. And we can see here move instruction, move destination comma source. Examples, move A comma hash 55H and move R0 comma A, move A comma R3. Instruction groups. The 8051 has 255 instructions. Every 8-bit of opcode from 00 to FFF used except for A5. The instructions are grouped into 5 groups. First one is arithmetic, second one is logic, data transfer, boolean and branching. Arithmetic instructions. The instructions perform several basic operations. After execution, the result is stored in the first operand. 8-bit addition, subtraction, multiplication, increment, decrement instructions can be performed. And it perform arithmetic operations like addition, subtraction, multiplication, division. Logical operations like logical OR, XOR, and NOT can be performed. ALU can also manipulate 1 bit as well as 8-bit data types. Individual bits can be set, cleared, complemented, tested, and used in logic computation. And when coming to 8086 registers, there are two types of registers in 8051: 8-bit registers and 16-bit registers. 8-bit registers are accumulator register A and register B, register banks, program status word PSW, and stock pointer SP. While coming to 16-bit registers, program counter PC and data pointer DPTR. Instruction register. This holds the instruction which is to be decoded, and program incrementer. The 16-bit register keeps incrementing the address in according to the program flow. Program address register. This is a 16-bit register. It holds the address of the code to be accessed. And when coming to the features of 8051, the first one is two 8-bit timers and four 8-bit ports, three internal and two external interrupts, one serial communication port, UART and bit as well as byte addressable RAM area of 16 bytes. 12 clock cycles are to constitute a one machine cycle, and 8-bit data buses and 16-bit address bus. 4 register banks, 32 purpose registers each of 8 bits, 16-bit program counter PC and data pointer, 4 KB on-chip program memory ROM, and 128 bytes on-chip data memory RAM. And we can perform several arithmetic operations like addition, 8-bit addition between the accumulator A and second operand. The result is always in the accumulator and the carry flag is set or reset appropriately. And ADDC, 8-bit addition between the accumulator and second operand and the previous value of the carry flag. Useful for 16-bit addition in two steps. The carry flag is set and reset appropriately. Subtraction. Subtract with borrow. Subtract an operand and the previous value of the borrow carry flag from the accumulator. Like the result is always saved in the accumulator. The carry flag is reset and reset appropriately. Increment. Increment the operand by 1. The operand can be register, a director address, and indirect address, a data pointer. Decrement. Decrement the operand by 1. The operand can be register, a direct address, and indirect address. Multiplication and division. Multiply A by B and place results in A. And divide A by B and the place results in A. And we can see some of the instructions. Addition A comma Rn, where addition of A plus Rn is stored in the accumulator A and its byte is 1. And with byte 2, addition of A comma Rx, where addition of A plus Rx is stored in the accumulator. And AAD A comma at the rate Ri, where the addition of A plus Ri is stored in the accumulator A and its byte is 1. And ADD space A comma hash X, where A plus byte size is stored in the accumulator. Addition with carry flag. ADD is place A comma Rn, where A plus Rn plus C is stored in the accumulator A and its byte is 1. And ADDC space A comma Rx, where A plus Rx plus C is stored in the accumulator C. Its byte is 2. ADD addition with the carry flag. ADDC plus A comma at the rate Ri, where A plus Ri plus C is stored in the accumulator A and its byte is 1. And ADDC space A comma hash N, where A plus byte size plus carry flag is stored in the accumulator A and its byte is 2. And subtraction with borrow, where A minus Rn minus 1 is stored in the accumulator and byte is 1. And SUBB space A comma at the rate Ri, where A minus Ri minus 1 is stored in the accumulator A. And SUBB space A comma hash X, A minus byte minus 1 is stored in the accumulator A and byte is 2. An increment operator. Increment A, where accumulator is incremented by 1 and is stored in the same accumulator and its byte is 1. And increment Rn. Rn plus 1 is incremented and this result is stored in the same Rn and its byte is 1. Increment Rx. Same. Rx is incremented by 1 and is stored its updated value in the same Rx and its byte is 2. Increment at the rate Ri. Ri is updated by 1 and is stored the result in the same Ri register and its byte is 1. Decrement A. Decrement A, the accumulator value is decremented by 1 and is the updated value is stored in the same accumulator and its byte is 1. Decrement Rn. Rn is decremented by 1 and it's saved in the same Rn and its byte is 1. Decrement Rx. Rx is decremented by 1 and is stored in the Rx. Its byte is 2. Decrement at the rate Ri. Ri is decremented by 1 and is stored in the same Ri and its byte is 1. Increment data pointer. Data pointer is incremented by 1 and is stored in the same register and its byte is 1. And multiplication of A B, where multiplication of both A into B is stored in the accumulator A, divisible, divisible by AB, where A is divided by B and is the result is stored in the accumulator A. And decimal adjustment of accumulator according to BCD code and its byte is 1. Thank you.